All right, howdy chem students. This is your fourth and final lesson in our solutions unit. And what we're going to be talking about today is how to dilute concentrated solutes or solutions in order to get solutions of a particular concentration that we're going for. So in other words, we're going to talk about two different scenarios and how to go about solving them. The first one is if we have a solid solute and we're trying to make a solution out of it. We're going to talk about how to figure out exactly how much solute you need to get a particular concentration of solution. So that's our first thing. Second thing we're going to talk about is how to go about diluting a concentrated solution down to a specified molarity. So let's get started. First situation is talking about how to prepare a solution from a solid solute. So in other words, anytime you've got like, you're trying to make salt water, or you're trying to make a sugar water, lemonade, what have you, something like that where we're trying to take something solid and dissolve it into some liquid to get a particular concentration. That's what we're talking about here. Okay, so the test that we will look at as our example is how to prepare a 1 molar solution of copper 2 sulfate in a 250 milliliter volumetric flask, or in other words, to create a 250 milliliter solution. All right. Now the first major step that we have to do, the main calculation we have, is to figure out how much solid we're going to need in order to get that concentration of solution. And we'll have to do two separate kinds of calculations in there. First, we'll need to figure out the number of moles of solute, and then from there we'll need to figure out the mass of the solute. Okay. So we start with our molarity equation. We know that the molarity of a solution is equal to the moles of solute divided by the liters of solution. In this case, we know the molarity of the solution we're trying to make, and we know the volume of solution that we're trying to make, so we're going to plug those in. So we put in our 1 molar solution for the molarity, and then we converted 250 milliliters into liters to put that in the denominator. Now in order to figure out the number of moles of solute, then we just need to multiply both sides of the equation by 0.250 liters. When we do that, we determine that in order to get 250 milliliters of a 1 molar solution, we're going to need 0.250 moles of our solute, our copper 2 sulfate. Now, I personally cannot actually go about measuring out moles. I don't really like counting individual molecules, and even if I did, I can't, so sucks for me. What I can measure easily is the mass of a solute. I can put it on an electronic balance and measure out a certain number of grams. So the next thing I want to do is convert from moles into grams, into something that I can actually easily measure out. So I'm going to do a molar mass conversion then. So I start with my 0.250 moles. And I set up my conversion factor, moles on bottom, grams on top, and I fill in the molar mass from the periodic table, which for copper 2 sulfate happens to be 159.62 grams per mole. So I multiply that out, and I determine that I must need 39.9 grams of copper 2 sulfate. That is something that I can easily measure out using my electronic balance. Okay, so if we were to then go about actually creating this solution, we would then weigh out 39.9 grams, and we would place it in whatever container we are making our solution in. In this case, it's a flask. Now from there, all we have to do is add the 250 milliliters of water that we need to make our solution. Now I highly recommend to you, both in the lab and also, if you're just making juice or whatever for yourself, start with just half the water and get it nice and mixed in. It's going to be easier to dissolve the solute if you have a lesser amount of water, so that you have a little bit of space in your container to actually swirl it around, stir it up, mix it up, whatever. Okay. So once you've gotten your solute dissolved in half the water, you can put in the rest of your water. And there you have your solution of a particular molarity. Done. Easy. All right. Now the other example that we are going to talk about is how to go about diluting a concentrated solution. So in this situation, we already have all of our solute dissolved in water. We've got a solution. It's just too concentrated or too strong. We want to thin it out, dilute it, weaken it a little bit by adding some more water to it. Okay. So let's say we've got that 1 molar solution we just made, but we actually want to dilute it down to just 0.3 molar. How we go about doing that is a little bit different because this time we don't have a solid solute, we have a solute already dissolved in water. Okay, so first step in figuring this out is to determine what volume of our stock solution or our concentrated solution we're going to need in order to end up with a solution with the right volume and the right molarity. Now it turns out there's a very easy little formula for us to use for this. It's molarity 1 times volume 1 is equal to molarity 2 times volume 2. Now all the things on the left side of this equation indicated with 1s, that describes our stock solution. Okay, so this is the molarity of our starting concentrated solution, and this is the volume of the concentrated solution that we're going to use. Everything on the right-hand side describes our new dilute solution. So this M2 describes our desired molarity for our new dilute solution, and V2 describes the desired volume of our new dilute solution. Okay. Now in this particular case, we know that we want our new solution to have a molarity of 0.3 molar. We want 250 milliliters of that solution. And we know that our stock solution is 1 molar in concentration. What we're trying to figure out right now is the volume of that stock solution that we need to use and get diluted. So we're solving for V1. I'm going to do that by dividing both sides by M1 to get just V1 by itself. And now I plug everything in. Again, all the 2's represent our new dilute solution, and all the 1's represent our old stock solution. So I put in all the information for my new solution on the top and for my old solution on the bottom. And whatever units I had for volume to begin with, those are going to be my new units of volume as well. All right. So when I multiply this through, I determine that I need 75 milliliters of my stock solution. So of the 250 milliliters of my new dilute solution, 75 of them are going to come from the concentrated solution, and the remaining amount to hit that 250 milliliters is just going to be water, which we're using to dilute it down. Okay. So what this means then is that to make this solution, we need to start with 75 milliliters of our stock solution, and then we add the remaining 175 milliliters necessary to get up to 250 milliliters. And that's it. Let's try one more example like this, where we're diluting a concentrated solution. All right. Now say I've got a 6 molar solution of hydrogen sulfate, and I take out 0.15 liters of it, and I then dilute it until I have 0.50 liters of solution. I want to figure out what's the molarity of my new solution. So what's the new concentration now that I've thinned out my starting solution of hydrogen sulfate? So again, every time I'm diluting down a concentrated solution, I'm just going to use the equation M1V1 equals M2V2, with everything on the left describing the stock solution and everything on the right describing the new dilute solution. Now what the question is asking me for is the molarity of my new solution, so that means I'm solving for M2 in this case. So I rearrange the equation to solve for M2 by dividing both sides by V2, and now I just plug everything in. Okay, so I start with M1 and V1. Those are the qualities of my concentrated solution that I'm starting with, and then divide by the new volume of my dilute solution. And I determine that the molarity of this new solution is 1.8 molar. Okay. Now we know that this makes sense because this is less concentrated than the solution that I started with. We started at 6 molar and now we're down to 1.8 molar. This makes sense because we're diluting it, we're adding more water, we're decreasing the concentration of the solute. If you ever solve a problem like this and you end up with a higher molarity for your dilute solution than you did to begin with, then you have made a mistake and you need to go back and fix it. All right. That is it for solutions, folks. Let me know what questions you have. Take care.